Hello, my name is Ms. Hayhurst, and today I will be teaching a lab where we will get to see the effects that certain things have on the rate of photosynthesis. And so, assuming that students have had somewhat of an introduction to photosynthesis by this point in our class the few days prior, we as a class should be able to describe and list the inputs and outputs of photosynthesis. For the purpose of this lab, I'm going to focus on the inputs because that's what we're going to be manipulating to change the rate of photosynthesis. And so students should be able to list the inputs as carbon dioxide, water, and light. And so knowing that those three things are the inputs for our reaction that we're looking at in plants, we should be able to describe how maybe manipulating one of those three factors would affect the rate of that reaction to occur. And so today we actually get to do a really cool lab to see the effects of one of those certain inputs on photosynthesis. And so in this lab, we're going to be using spinach leaves. And so we'll be looking at the rate of photosynthesis in these spinach leaves, which is super cool. And so before we begin, everyone should check their boxes to make sure that they have all of the correct materials. And so be sure we all have 2 plastic straws, 2 plastic syringes, 1 plastic stirrer, 2 small beakers, and 1 large beaker filled with 1,000 milliliters of water, as well as a scale, filter paper, and baking soda, also known as sodium bicarbonate. And so in today's lab, we are going to begin by measuring out our sodium bicarbonate and making a sodium bicarbonate water mixture. And so the reason we're doing that is so that we have that water and carbon dioxide source so that we can drive photosynthesis in our reaction. And so I already have my 1,000 mils of water measured out. I am then going to measure out my baking soda to pour into my water. First got to zero the scale to be sure I'm getting an accurate measurement. Like I said, 10 grams into the 1,000 mils of water to get a 10-to-1 ratio. Stir that up with your plastic stirrer. Awesome, okay. And so in the setup of this lab, we're going to separate into 2 groups. So I'm going to have 2 students work on the light reaction and 2 students work on the dark reaction. And the reason we want to test both is to be, at the end, compare the 2 and see how the exposure to light or lack of exposure to light would affect the rate of photosynthesis. And so before we begin, we're all going to cut our leaves up. And so to do so, we're going to take our plastic straw and our spinach leaf, and we're going to poke holes through the leaf with that straw, which is going to make little circles or leaf chads. And so we want to get about 10 leaf chads per experiment. So we want 10 for the dark experiment and 10 for the light experiment. And so while I'm cutting these out, I'll explain a little bit more about the lab setup. And so once these chads are all cut out, we're going to want to remove the oxygen from these leaf chads to get them to sink to the bottom of our solution, because we're going to actually measure the rate of photosynthesis by the oxygen they produce. And so when these leaf chads produce oxygen, they're going to rise to the top because they're going to become more buoyant and therefore will rise to the top. And so as photosynthesis is occurring, they're going to rise, and that's how we are going to measure the rate. Okay, so I have about 10. Does not need to be exact, just a number probably at least 10 or above, so that we're getting accurate data. And so now once I have these leaf chads, I'm going to take my plastic syringe. I'm going to remove the top and dump those leaf chads in the syringe. Ah, they've fallen. Okay, so then once our chads are in the syringe, go ahead and place that topper back on. And so now we have a closed syringe with the leaf chads inside of the syringe. And from there, I'm going to pull up some of our sodium bicarbonate water solution. And so I have those leaf chads in the solution. And if you can see, I have a little bit of an air bubble at the top. And so to get rid of that, I'm just gonna push up until the water rises and there's no more air bubble. Some water might spill out and that's okay. And so now we have the leaf chads at the top, but like I said, we want them to be on the bottom so that we can then measure the rate of photosynthesis by how quickly they rise. And so to get them to the bottom, we're going to create a vacuum inside of our syringe to remove the oxygen from those leaf chads. And so to do so, we're going to place our thumb on top of our syringe and pull down on the plastic stopper. It's a little tough. Once we let go, our chad should start to sink. We got a couple floaters. Some of them are a little stubborn, so you might have to do this a couple times to get all of them to sink. And if there are some that just you can't get to sink, we'll just pull those out of the experiment and not include them in our data. And so like I said, a lot of them are starting to sink to the bottom. And so once we have at least most of them, there's the last one. Once we have at least most of them to the bottom, we're going to then take our small beaker, and this is where we're going to separate into our two groups. And so each group should have one syringe with their sunken leaf chads, and they should take their own small beaker with them. And so, assuming I am the light group, I am going to take the insides of my syringe and dump them into my beaker. And I'm going to go to a light source and put my beaker under the light source so that it can receive light. And so we will be taking data for 15 minutes every minute. So immediately after setting our beaker under the light, we're going to start our timer, which I have my timer set to the side. And when that timer hits 1 minute, I'm going to record how many chads have floated to the top. I'm going to do that every minute for 15 minutes with an ongoing score. So if in the first minute, or say in the fourth minute, we get 3 chads to rise, and then in the fourth minute we get 7 leaves to rise, we're going to do an ongoing score. So then we would have 10 at 7 minutes because we had 3, and then we're adding as we go. And so students are going to get to graph their data. So we have the light's horrible, sorry. We have a table where they're going to input their data, and then they're going to go back to their tables and get their partner's data from the opposite experiment. And so in this case, I would be going to get my partner's data for the light experiment. And I'm going to then graph the 2 lines on a graph paper to see the relationship between the 2. And so we would also be needing to include a legend and our AXE titles, and would then get to see how the light or lack of light affected the rate of photosynthesis by the lines we form on the graph. And so before getting to that graph, we would discuss the dependent and independent variables that we were looking at so that we would get the axes correct. And so in this experiment, the independent variable, or the variable that we're changing, is the time. And so our x-axis is going to show time, so it's going to be 0 through 15 because we are recording for 15 minutes. Our y-axis is going to be number of leaf chads to rise, and so that's how we are measuring the rate of photosynthesis. And so some students may put rate of photosynthesis as their y-axis. I would probably direct them to change that to a number of leaf chads that rise, and we use that number to represent the rate of photosynthesis. And most of the data on this experiment seems to work out. We usually have all of the leaf chads in the light experiment rise by the end of the 15 minutes, and usually if any in the dark experiment rise, it's maybe 1 or 2. And so students really get to see that when we are manipulating that light factor, and we are either exposing the leaf chads to light or taking that light away from the leaf chads, the rate of photosynthesis is really going to change. And so after this experiment, I really like to kind of promote those higher level thinking questions in students and get them thinking about other things that maybe aren't a part of those 3 inputs to photosynthesis that would affect the rate of photosynthesis. And so maybe certain things like a percentage of carbon dioxide that we used in our solution would come up, or maybe the amount of water that we would use would come up, because those are the inputs and the things that students would immediately think about. But I would like to kind of guide them to thinking about things like different colored light bulbs, or humidity levels, or temperature, certain things that aren't directly related to the inputs that would potentially have an effect on the rate of photosynthesis. And so students usually have a lot of fun with this lab, and I think it's a great way to get them engaged in the material and thinking about other factors that affect the rate of photosynthesis. So hope you enjoyed my lesson.